Today we are going to discuss the last point of this topic, that is nothing but laws of exponents for real numbers. If you know already how we have studied the laws of exponents in the earlier classes. We know there are 7 laws of exponents. Once again we are going to revise the same laws, okay, and the same laws are also applicable for the real numbers also. But before starting with the laws of exponents, first of all we will see what exactly is an exponent. Okay, how do we come to this word exponent, or similar words are power or index? When we multiply a same real number to itself number of times, okay, in this way we get the exponent. For example, suppose we are doing the product of the same real number a m number of times. That is nothing but we will write a into a into a into a up to so on m times. So m times we have done repeated multiplication of a with itself. So in the form of an index, this can be written as a raised to m. So here a raised to m means that repeated multiplication of a m number of times. So we write there a raised to m. In this exponent form a raised to m, we call a as the base, means the number which is repeating, and m as the exponent or power or index, means it is m is the number of times the given number is repeating. Getting it? So a is called as base and m is called as exponent or power or index. So this is the definition of exponent. If you multiply a same real number to itself m number of times or many number of times, we get the exponent. Okay, so in this way it is defined, and in a raised to m, a is the base, m is called as exponent or power or index. All these are similar words. Now we are actually going to start with the laws of exponents, which we have studied already in the previous classes. So first law of exponent is this: a raised to m multiplied by a raised to n is equal to a raised to m plus n. So what do we see here? Here is the multiplication of the two numbers having same base but different exponents. So here we can say that in the multiplication of two numbers in the form of exponent, if their bases are same and there is multiplication, so we can add the powers. So here we have kept the same base a and powers are added. So this is the first law which deals with the multiplication of the numbers having same bases but different powers. The second law is quite similar to this one. Instead of multiplication there is division. So a raised to m divided by a raised to n is equal to a raised to m minus n. So here what do we see? We have same bases but different powers, and there is division of these two numbers. And in the division, what we do, we keep the same power and we subtract the exponents. That's why we have written a raised to m minus n. Okay, that is nothing but here a raised to m divided by a raised to n can be written in this form also, in the form of a fraction, but the answer will be same, a raised to m minus n, subtraction of the powers. The third one is a raised to m into b raised to m is equal to a into b whole raised to m. Now what do you see here? In this third law of exponent, you see that bases of both the numbers are different but their powers are same. So in this case we have kept the power same and we have multiplied both the bases. So here you have to remember that if two numbers are there in the exponent form with the different bases and same power, we keep the same power and we simply multiply the bases to get the answer. Similarly, if instead of multiplication there is division, so what we do, again a raised to m divided by b raised to m, if it is there, we keep the same power m and simply we divide the numbers a and b. Okay, that is nothing but a raised to m divided by b raised to m is equal to, we have kept the power common and base we have written as the division of the two bases. like we did in the third law for the multiplication. So this is the fourth law of exponent. Next, fifth one. Here we have a raised to minus m is equal to 1 upon a raised to m. So if we have given negative exponent, to convert negative exponent into a positive exponent, what we do, we write 1 upon a raised to positive of the given exponent. Getting it? So this is very simple to do. Similarly, if you have given positive exponent, that is a raised to m, and if you want to convert it in the form of a negative exponent, then that can be also done in the same way. So a raised to plus m can be written as 1 upon a raised to minus m. So this is the fifth law of the exponent. Now let us start with the sixth law. Here what do we see? A raised to m, again whole raised to n. So here we see the power of the power, a raised to m raised to n. So if there is power of the power, we multiply the powers. So base has been kept same, and simply we have multiplied the powers, m into n. Getting it? So if there is power of the power, we multiply the powers. Just remember this rule number 6 of the exponents. The seventh law of the exponents is very simple. Any real number raised to 0 is always equal to 1. Okay, always you remember this, except 0, this property is true. A should not be equal to 0. That is the case. So here we can say that any real number except 0, if we take its power as 0, its answer is always 1. That is why we have written a raised to 0 is equal to 1. So these are the 7 laws of exponents which we already have studied in the earlier classes. Once again, to revise these laws, what we will do, we will just see some questions which will be helpful for us to revise all these laws of exponents. So we are going to evaluate this one. First one, 7 cube into 7 square. What do we do here? To evaluate this, we can see that there is multiplication of both the numbers. They have same base but different powers, and we know that if bases are same, then we keep the base same and simply we add the powers. So the base we have written 7, power is 3 plus 2. In the multiplication we have to add the powers. So that is nothing but 7 raised to 5. 7 raised to 5 is nothing but 7 multiplied by 7 multiplied by 7 multiplied by 7 multiplied by 7. So 5 times multiplication of 7, which will give us 16,807. Okay, so repeated multiplication of 7 5 times. Okay, so this is very simple to do. Second question, we have given 5 raised to 13 divided by 5 raised to 9. Again the same question. Here we have same basis and different powers. Every time you just analyze the given question. Here we have given the same basis and different powers. So what will we do here? We'll keep the same base and simply we will subtract the powers as there is division. So here we can write 5 raised to 13 divided by 5 raised to 9 is nothing but 5 raised to 13 upon 5 raised to 9. Both are quite similar, and as there is division of these two numbers, simply we will subtract the powers. So 5 raised to 13 minus 9, which will give us 5 raised to 4, which is nothing but 625. Okay, 5 multiplied by 5 multiplied by 5 multiplied by 5, that is repeated multiplication of 5 with itself 4 times will give us 625. So this is very simple to do. Next one, 3 raised to 4 divided by 3 raised to minus 8. Here in this question, what we will do is, again we can see that there is division of the same numbers with the same base. So simply we are going to subtract the powers. So 3 raised to 4 divided by 3 raised to minus 8 is nothing but, okay, as the bases are same and powers are different, we are going to subtract the powers. Remember it. Okay, so we'll write 3 raised to 4 minus 8. Okay, because we have to subtract the powers. The power of the 3 in the numerator is 4 and the power of the 3 in the denominator is minus 8. So here we have written 3 raised to 4 minus 8. Okay, so that is nothing but 3 raised to 4 minus will become plus 8. Okay, so 3 raised to 4 plus 8, which will give us 3 raised to 12, which is the answer of this question. Okay, so this is also exactly the same question like the previous one. Third question, the fourth one, 5 raised to minus 3 into 2 raised to minus 3. Now which law we have to apply? You have to think about it. See here, what do we see? here we have different bases. Bases are not equal, but their powers are equal. And in this case, if bases are not equal and powers are equal, what we do? We simply multiply the bases and keep the same power. So answer of this one, we will write, we have simply multiplied the bases 5 into 2 and we have kept the same power for the answer, that is minus 3. So this is equal to, we can write 10 raised to minus 3. 10 raised to minus 3. Now again we are going to apply our another law of exponents. If you want to convert this power as positive, what we need to do? We need to write that is equal to 1 upon 10 raised to 3. If you want to convert negative power into a positive power, so 1 upon 10 raised to 3 can be written for this. So again that is equal to 1 divided by 10 cube is nothing but 1000. Okay, so in this way this can be solved. 10 raised to 3 is nothing but 10 into 10 into 2, 10, which will be giving us 1000. So remember this. Only thing is that you have to compare the given question with the laws which we have studied. You need to decide in which format it comes and you have to apply the law accordingly. Next one, 73 raised to 6 multiplied by 73 raised to minus 6. So here what we can see here, in this question bases are same and powers are different. Remember that if there is difference in the sign, means powers are different there. Okay, so here what we can do, we have same power, same base and different powers, means we will keep the same base, and as there is multiplication between these two numbers, we will simply add the powers. So we have written 73 raised to 6 plus minus 6, because by the law of multiplication of these two numbers, if there are same bases, what we do, we keep the same base and we have to add the powers in the multiplication. So we have added the powers. The power of first number is 6 plus the power of second number is minus 6, that you need to write in the bracket. So next step, we can write 73 raised to 6 plus into minus will give us minus 6. So 73 raised to 6 minus 6, that is nothing but 73 raised to 0, and we know that any real number except 0 raised to 0 is always equal to 1. So 73 raised to 0 is equal to 1. Okay, so this is the answer of fifth question. Now let us discuss the next one. 2 raised to 4 raised to 3. So here we can see there is power of power. So we can compare this with the sixth law which we have just studied. Okay, if there is power of power, what we do? We multiply the powers. So here we can write 2 raised to 4 raised to 3 is nothing but 2 raised to 4 into 3. That is equal to 2 raised to 12. And 2 raised to 12 is nothing but repeated multiplication of 2 with itself 12 times will give us 4096. Okay, so this way we can use the laws of exponents to solve these all questions you have studied in the previous classes. So there will not be any problem to understand these laws of exponents. So what new are we going to do this year? The same laws of exponents we are going to use for the real numbers, means we are going to use the same laws for the powers which are not the integers. Getting it? So we are going to use it for all the real numbers which are the powers of given numbers. Getting it? So same laws will be there. There is no change in the laws. Laws will remain same. Okay. Only thing is we are going to use it for the exponents which are not integers. Getting it? So this is the new thing which we are going to. Now we are going to discuss some more problems based on the laws of exponents where powers will be real. Okay, so first one, 2 raised to 2 upon 3 into 2 raised to 1 by 3. Okay, so simply we are supposed to use the laws of exponents which we already have discussed. Getting it? These questions will be also solved in the same way we have solved the exponents or the questions where the exponents were integers. So what do we see here? Here we have same base but different powers and multiplication. In such kind of cases, what we do? We keep the same base and simply we add the powers. Okay, so here we can write 2 raised to 2 upon 3 plus 1 upon 3. That is nothing but now we will just add the powers. Okay, here to add the powers there is same base, so simply we will add the numerators. So 2 plus 1 upon 3, that is nothing but 2 raised to 3 upon 3 will get 3 will get cancelled to each other, so we will get 2 raised to 1. 2 raised to 1 is nothing but 2, which is the answer of the given expression. So this is about the first one. Let us see second question. Here we have 7 raised to 1 upon 5 divided by 7 raised to 1 upon 3. So once again here we can see that there is same base and different powers. If there is same base and different powers, what we do? We keep the same base and we subtract the powers. So again let us do that. So 7 base has been kept same, powers are being subtracted, 1 upon 5 minus 1 upon 3, that is equal to, now we have to do the calculation in the power. Okay, so here 1 into 3 we can write 3, cross multiplication we are doing, or you can use the method of LCM also, no problem with that also. Okay, so 1 into 3 I have written 3 minus 1 into 5, that is nothing but 5. So subtraction of these two numbers divided by, in the denominator we have to multiply the denominators if you are using the method of cross multiplication. Okay, to subtract the fractions. So that is equal to 7 raised to minus 2 divided by 15. Okay, 3 minus 5 is nothing but minus 2. Why? Because if there are different signs, we give the sign of the greater number, which is negative, and then we subtract the numbers. 5 minus 3 will give us 2. So your answer is 7 raised to minus 2 upon 15. Next question. Here we have 27 raised to 3 upon 4 multiplied by 3 raised to 3 upon 4. So what do we see here? We have different bases but same power. Okay, in such kind of cases what we do? We simply multiply the bases and keep the power same. So here we'll write that is equal to 27 into 3 and power we will be kept common, that is 3 upon 4. So that is equal to 81. 27 3s are 81 raised to 3 by 4. Okay, now again if you want we can simplify this also. Now afterwards we are again going to see the problems based on this, but then too I will explain this how to solve such kind of questions. We have 81 raised to 3 upon 4. You just see the, means what we can say here, this is the 4th root of 81 cube. Okay, so what you have to see, if power is a rational number, you just see which number is there in the denominator. In the denominator we have 4. So what you will do, you just see about base, you just see which number can be multiplied to itself 4 times to get 81. Okay, in that way we are going to think it. Okay, so here if you think in that way, because 4 is in the denominator of the power, means what are we going to do? We will represent base as the multiplication, repeated multiplication of a number 4 times. So 81 can be written as repeated multiplication of 3 4 times, that is 3 into 3 into 3 into 3. Okay, 3 raised to 4. So there 3 raised to 4 raised to 3 upon 4. Again next step, we know that if there is power of power we can multiply the powers. So next step we have written 3 raised to 3 multiplied 4 multiplied by 3 upon 4. Again 4 will get cancelled and we can write that is equal to 3 raised to 3, and 3 raised to 3 is nothing but 3 cube, which is nothing but 27 here. So this is very simple to do. Again we are going to do many questions like this afterwards. I will explain again. Okay, we just see it. Fourth question we have is 3 raised to 1 upon 5 raised to 4. This is very simple to do. What we will do here? Here we have power of power. And if there is power of power, simply we will multiply the powers. Okay, so 3 raised to 1 upon 5 multiplied by 4. And whenever we multiply the fractions, we multiply numerator to numerator and denominator to denominator. So 4 we will consider as 4 upon 1. So their multiplication of the numbers in the power is nothing but 4 into 1, 4 divided by 5. So 3 raised to 4 upon 5 is the answer of that one. Okay, next one we have 12 raised to 1 upon 5 divided by 12 raised to 1 upon 5. If you have a bit common sense, you can see that it is nothing but division of the same numbers. So without using any laws of exponents also, you can directly write the answer of this one as 1 because it is the division of the same numbers. Okay, because we know 10 upon 10 is nothing but 1, 15 upon 15 is nothing but 1. Like that, same number divided by same number, we can always write answer as 1. Okay, so here directly also you can write the answer 1 is there. We can use the laws of exponents to do this. Okay, so here we have same basis and same powers also, so it doesn't matter which laws you are going to use. We have two laws for the same basis and two laws for the same powers. Okay, even if you use both the laws, you are going to get the same answer only. Okay, here you see we have considered that bases are same and there is division, so we have to subtract the powers. So it can be written as 12 raised to 1 upon 5 minus 1 upon 5. So that is nothing but 12 raised to 0. 1 upon 5 minus 1 upon 5 will give us 0, and anything raised to 0 is always 1. Okay, we know that real number raised to 0 except 0, okay, is always equal to 1. Now, after this, we are going to solve the problems what we have seen in question number 3 here, like 81 raised to 3 upon 4. How to calculate such kind of answers. Okay, so next question, we are going to some more questions like that, so that you will be finding it easier to solve. Okay, that is also very easy to do. The similar technique we are going to use there. Now, let us start with the third question, and the question is to evaluate the following expressions. Okay, we have given these many, 6 are there. First one, 9 raised to half. One by one we will be doing it. Okay, and it is very simple to do. Let us start with the answer of first question. The first one given to us is 9 raised to half. Now, as per what I told you, you see the power of the given number. Base is 9, power is 1 upon 2. Okay, and power is a rational number. And whenever your power is a rational number, you just think about denominator. There is denominator is 2. So what you do? You just think about, okay, you consider power as 2. Which number should be multiplied itself 2 times to get 9? So the base we have to write by taking the same power which is in the denominator of the given power, a given number. Getting it? So here we know that 9 can be written as 3 square. So see, here we have equated the powers. Okay, the power of 3 is also 2, and then denominator, whatever is there in the original power, is also 2. Okay, so in that way we have to equate. So what we have to do, we have to equate the power of the base and the denominator of the original power. Getting it? So in this way we can write this 3 square raised to 1 upon 2. Now we can see that there is power of power, and whenever there is power of power, we can multiply the numbers, multiply the powers. So this will be 3 raised to 2 into 1 upon 2. Now 2 will get cancelled, so we'll be remaining only with 3 raised to 1, and 3 raised to 1 is nothing but 3. Getting it? So this is very simple to do. As I told, everything depends on the power, and that too, if the rational power is there, it depends on the denominator of that rational power. Okay, because given number we are going to express in the form of power of that number only. Getting it? So second question, you see we have given 64 raised to 2 upon 3. Okay, now here once again you see that there is 3 in the denominator of the power. So 64 we are going to try to write as cube of some number. Okay, to bring 3 in the power of base. Okay, so we know that 64 is nothing but cube of 4. Okay, so in this way you are going to find it. So 64 is simply replaced by 4 cube and raised to 2 upon 3. So here once again you see that power of the base and the number in the denominator of the original power are now same. Okay, so in this way you are going to think it. Okay, that is equal to, now there is power of power, so there will be multiplication of the powers. 3 will get cancelled, so we can write it is 4 square. So 4 square is nothing but 16. Okay, so this is very simple to do. Okay, next let us start with the third question. In the third question we have 32 raised to 3 upon 5. Now once again you just focus on the power. Power is a rational number, and we will focus on the denominator of the power. Denominator of the power is 5. Getting it? Means the base we are going to write as fifth power of some number, and we know that 32 is nothing but fifth power of 2 raised to 5. So 32 is written as 2 raised to 5, and whole raised to 3 upon 5. Again there is power of power, so there will be multiplication of the powers. Again 5 is going to get cancelled there, so we'll get 2 cube, and 2 cube is nothing but 8. Okay, 2 into 2 into 2. So this is very simple to do. Okay, in all the question you might have observed that we are using the same technique to solve it. Now let us solve the fourth question. In the fourth question we have given 16 raised to minus 3 by 4. No change in the technique. You just see the power. Power is a rational number. We will be focusing on the denominator of the power, which is nothing but 4. Means given number, that is base 16, we will try to express as fourth power of some number. Okay, so you have to search for a number which will be multiplied itself 4 times to get 16, and that number is nothing but 2. So 16 can be written as 2 raised to 4. Getting it? So again there are powers of powers, so this will be written as 2 raised to, now that minus sign is also there, 4 multiplied by minus 3 by 4 actually we can write. For that minus I have kept common outside the bracket. Inside the bracket I have multiplied the remaining powers, so there we can write 4 multiplied by 3 upon 4. Again 4 and 4 is going to get cancelled, so we'll be left with 2 raised to minus 3. Now if you want to try the answer further, what we can do, if there is negative power and if you want to convert that power into positive, we will write it as equal to 1 upon 2 raised to 3 to make the power positive. Now we can calculate that 2 cube, which is nothing but 8. So answer of this expression is nothing but 1 upon 8. 2 cube is 8, so 1 upon 8. Now let us start with the fifth question. Our fifth question is 81 raised to minus 5 by 4. So again we are going to do in the same way. We will focus on the power. Power is a rational number. We will focus only on the denominator, which is 4. So we will try to write base 81 as fourth power of some number, and we know that 81 is nothing but fourth power of 3. So that can be written as 3 raised to 4 and whole raised to minus 5 by 4. Okay, again we come see here that there is multiplication, there is power of power. So if there is power of power, we will multiply the powers. So minus sign once again we have taken common, and multiplication of the powers, that is 4 into 5 by 4. 4 will get cancelled, so this will be equal to 3 raised to minus 5. Okay, then if you want to convert this power into a positive one, that can be written as 1 upon 3 raised to 5. 3 raised to 5 is nothing but 243, so that is equal to 1 upon 243. This is the answer of fifth question. Now I hope you might have got the idea how to solve this. Now see sixth question. In the sixth question, what do we see? We have given 729 raised to minus 3 upon 2. Rational power. We will focus on the denominator of the power, which is 2. Means we have to see 729 is the square of which number? Now 729 is square of 27. So we have written that is equal to 27 square whole raised to minus 3 by 2. So again, as there is power of power, we can multiply the powers. Minus sign can be kept common. 2 will get cancelled. So we can write this as 27 raised to minus 3. If you want to convert this power as a positive one, that can be written as 1 upon 27 cube, and that is equal to 27 cube is nothing but 19,683. So answer of this one will be 1 upon 19,683. So this is the answers. This is the way of solving this. The technique is very simple to do. How to solve such kind of questions, you might have got the idea. You just think about the power. If power is a rational number, we will think about denominator, and we will try to convert base of the given number in that many number of powers. Okay, like suppose in the first question, what do we see? We have given 9 raised to half. Okay, denominator of the power is 2. Means we have to express 9 as second power of some number. Second power is nothing but square of some number. So 9 can be written as square of 3. Getting it? So like this all questions we have solved. There is same technique to solve these all questions. Nothing is different. It's very simple to do. I hope you have enjoyed this. Now let us discuss some higher order questions based on the exponents of the number. Okay, so let us start with the next question. our next question is to simplify 256 raised to minus 4 raised to minus 3 by 2. Here, see, this question you have to analyze properly. We have given 256 as the base and power of 256 is minus 4 raised to minus 3 by 2. So this you have to remember. It is not like the power of power. Getting it? So here what we are going to do here in this case, we will do it a bit in the different way. 256 is our base and its power is minus 4 raised to minus 3 by 2. So first of all, we are going to focus only on the power part of this question. We will be solving only for power first. Afterwards, we will be doing for the base. So let us focus only on the power. We have given the number 256 raised to minus 4 raised to minus 3 by 2. So now we will think 256 raised to minus, we will keep as it is, that minus sign also we are not going to change at all. Okay, so we will be focusing only on 4 raised to minus 3 by 2. So there 4 raised to minus 3 by 2 we are going to solve first. So there what we can do, once again like previous questions, we will be focusing only on the power, which is a rational number. So we will consider its denominator, which is 2, means base 4 we have to write as second power of some number, that is square of some number. We know that 4 is nothing but square of 2. So next step, it is written like 256 raised to minus 4 has been written as 2 square raised to minus 3 by 2. Now here in the power you can see that there is power of power. As there is power of power, we can multiply the powers. So there we have written 256 raised to minus 2 raised to 2 multiplied by minus 3 by 2. Now again that 2 in the numerator and denominator will get cancelled. So we will get here 256 raised to minus 2 raised to minus 3. Okay, so this is what we have got for this one. Now we have 2 raised to minus 3. This can be written by converting the power as positive. So we have 2 raised to minus 3. If we want to convert this power into positive 1, what we can write? This can be written as 2 raised to 1 upon 2 raised to 3. So next step we have written that 256 again as it is, that minus sign also we have kept as it is, and 2 raised to minus 3 we have written like 1 upon 2 raised to 3. Okay, by using our law of exponent. Okay, I hope you have understood this step. Remember this, when we have negative power and we try to convert that negative power into positive one, we have the law a raised to minus m is equal to 1 upon a raised to plus m. So simply we have used that law. Next step, we will simply calculate the denominator. So 256 raised to minus sign I have given to the numerator, minus 1 divided by 2 cube is 8. Now we have come to the basic form. Now we are going to completely consider the expression which we have now. Okay, so we have 256 as the base and minus 1 upon 8 as the power. Okay, so as power is rational, we are going to focus only on the denominator of the given power. Denominator of the given power is 8. So we will express base as 8th power of some number. Now we have to think which number can we get which will be multiplied to itself 8 times to get 256. That number is nothing but 2. So 256 can be written as 2 raised to 8. Okay, so 2 raised to 8 multiplied by minus 1 upon 8. Okay, now as there is power of power, we can multiply the powers. So we can write 2 raised to 8 into minus 1 upon 8. 8 can be cancelled. So we can write 2 raised to minus 1. To convert the power into positive 1, we can write this as 1 upon 2 raised to 1. That is nothing but 1 upon 2, which is answer of this expression. So it is very simple to do. Only thing is that you need to be very well with the knowledge of the power laws of exponents, and you have to apply those laws properly. Okay, and to solve such kind of questions, I have given you simple technique how to solve the given expression if there is a rational power. Okay, if there is a rational power, we completely focus on the denominator of that rational number. And whatever number is there in the denominator, we try to convert base as that many number of powers of some number. Okay, so if we use this simple technique, such kind of questions can be evaluated very easily without taking much efforts. This is very simple to do. We are going to start with next question. One more question we will see of simplification. This is also a very easy question. You just see the question what is given to us. We have given 5 multiplied by 8 raised to 1 upon 3 plus 27 raised to 1 upon 3 whole cube, and this whole expression raised to 1 upon 4. Okay, now first of all let us write the given expression as it is. Now we know that 8 raised to 1 upon 3 is nothing but cube root of 8, and 27 raised to 1 upon 3 is nothing but cube root of 27. So directly also you can write the answers. 8 raised to 1 upon 3 is nothing but cube root of 8, which can be written as 2, and 27 raised to 1 upon 3 is nothing but cube root of 27, which is nothing but what we can write 3. Getting it? So you can solve this by using our regular method also. 8 raised to 1 upon 3 we have. Okay, the denominator of the power is 3, so we have to find out a number which can be written as cube of some number c. So 8 has been written as 2 cube, so 2 cube raised to 1 upon 3. And similarly for 27, the same number is there in the denominator of the power, which is 3, and we know that here we have to express base as third power of some number, that is cube of some number. So 27 can be written as 3 cube. Okay, next step, again inside the bracket we can see that there is power of powers, so powers can be multiplied. So 5 multiplied by 2 raised to 3 into 1 upon 3 plus 3 raised to 3 into 1 upon 3 we can write, and whole raised to 3 whole raised to 1 upon 4. Remaining terms we have written as it is. We are just starting from the terms which can be easily simplified. Now that 3 is going to get cancelled from both the powers, so we'll be simply left with 5 into 2 raised to 1 plus 3 raised to 1 raised to 3 and whole raised to 1 upon 4. Okay, so next step we can write that is equal to 5 multiplied by 2 plus 3 cube raised to 1 upon 4. That is nothing but 5 multiplied by 2 plus 3 is 5 cube raised to 1 upon 4. Now 5 into 5 cube. Here we are going to use the law of exponents. We have same base, so simply we can keep the same base and multiply the power, add the powers, Here power of 5 is 1, remember that. And second number 5 we have there 5 cube. Okay, so we can keep the same base 5 and simply we can add the powers 1 and 3. So this can be written as 5 raised to 1 plus 3, that is 5 raised to 4 raised to 1 upon 4. Again there is power of power, so powers can be multiplied. 4 into 1 upon 4, 4 can be cancelled, so we'll get 5 raised to 1, which is nothing but 5. So above expression can be simplified to, okay, so it is very easy to do. Okay, only thing is that you need to observe it very carefully and you have to follow the basics which we are using. It is very simple to do. Now I have given you some questions for homework. I hope you will do these questions easily. The first question is to evaluate the given expressions. This is very simple. These all questions are based on the laws of exponents which we have already done. So these 8 questions you can do easily simply by using the laws of exponents. You see which laws are applicable to solve these 8 questions. Second question is to evaluate the expressions, and this kind of questions can be solved simply by thinking of the power. I told you technique how to do this. Okay, suppose we are solving second question here, 32 raised to 2 upon 5. So what we'll do, we will focus only on the power which is rational number. Again in that we will focus only on the denominator which is 5. So given number base, that is 32, we need to express as fifth power of some number. Okay, so 32 is nothing but fifth power of 2. So accordingly you can solve this further by using the laws. You see all the questions properly. All these 8 questions in the second question are really very easy to do. Question number 3, I have given some questions for simplification. Here it will be real test for you all people. You just do these questions carefully. First question is very simple. First of all, you solve the base. After solving the base, do a half power of that one, means square root of that number. Second is easy. Third question, you need to be again very much careful about that one while solving it. Or you can simply do it by multiplying the powers, because there is simply power of power of power. So you can multiply all the powers and solve, or you can solve by one terms. First of all, solve the simple bracket, then solve square bracket, then solve this bigger bracket. Okay. Fourth question is also very easy. Fourth question, solve all the denominators first, get the answers of denominators, then whatever fractions you will get, add all those fractions. Okay, it is that simple to do. Fifth question is also very simple to do. You have to use the laws of exponents to solve this question. So in this way, this chapter is complete. I hope you all have studied this well. Complete the homework. All the best.